next session is about building your modern data warehouse in Azure. Our speaker is Chiu Kiang Phua. I hope I'm pronouncing it right. He's the owner of PCK Consulting. He's a Microsoft MVP for data platform, and he's the community leader for Malaysia. He's the organizer for SPAN. Welcome to the sessions, CK.
Yeah, thanks, Phua.
All
Can you hear
right.
me?
Yeah, we can hear you.
Okay, cool.
I already gave you presenter, so
Okay,
you'll be able to present.
sure. Okay, so I can start, yeah? You can see my screen, right?
There you go. Now we can see you.
Can see. Okay, cool, thanks. So yeah, good afternoon, everyone. Yeah, and thanks for staying on for my session. And yeah, as Pio mentioned, yeah, my name is it's pronounced Phua Chiu Kiang. Yeah, almost got it right. So usually that name is quite familiar with a lot of people. As in not my name, but Phua Chu Kang. Yeah, so it sounds quite familiar. But yeah, people call me PCK as well. Right, so I'm the sort of the owner of PCK Consulting. We do basically data management consulting, professional services for generally the data management around Microsoft stack of technologies. Yeah. So okay, what I'll be presenting about today is on building the modern data warehouse on Azure. And essentially, I will be going through this slide here that you see right now. And if you've already delved into Azure, you know that there are so many features and products and services in there right now, and it gets a bit confusing sometimes, right? To say the least. So what today's session is about is mainly to try to help you navigate through all these services and products when you want to build a data warehouse, right? So I'll be going through the various components of the things that you need to do essentially to build a data warehouse, right? From these points of view like ingestion, storing, preparation, and then modeling it and serving the data. And because there's so many types of different products and services within Azure itself, right? We're not even talking about the third-party ones and other products. So within Azure itself, so this session will focus mainly on the products and services that you can get in Azure, and why you would want to use this product, or which one to use for what purpose, what's the advantage or disadvantage of one product over one service over another one, and so on, right? So hopefully by the end of this session, you get a little bit of insight into the various mechanisms that are in Azure to help you build that data warehouse that you want to build, and also choose the right tool for the right place and at the right time. Yeah. So okay, let's before we go into further into all these different components of the data warehouse, let's take a look at how a traditional data warehouse looks like, yeah, or analytics platform looks like, right? So I think if you build a data warehouse before using the traditional method, you will be quite familiar with this model where we have our data sources, right? So most of these data sources are relatively structured data, right? OLTP data, your ERP, your line of business data, and usually we will have some kind of ETL tool to do the extraction, transformation, and then loading it into our storage. And these ETL tools could be like your SSIS and so on. And then we would store it into usually some type of relational database, or maybe some kind of fact table, star schema, and so on, before we serve it out to our BI tools for the presentation layer and the applications. Right? Now, in the what has evolved to what we call now the modern data warehouse is mainly because of the change in the type of data and the amount of data that we are getting. Yeah. So, for example, a lot of the time now, we are not just going to load data from our relational data sources and so on. There's also a lot of data coming from your devices, your Internet of Things stuff, right? Streaming data. So from your social networks, yeah, sensors, your clickstream data, web data, audio, video, all kinds of different stuff that can potentially be useful in a data warehouse business environment today. Yeah, so this change is mainly precipitated by this need for storing more data at a faster pace and more types of different unstructured data. Yeah, so we see that how it has evolved is now instead of extracting and transforming it, then only loading it into a relational source, the strategy has somehow changed where we ingest all that data first. Ingest as in we load it first, then only we decide how to deal with it. Yeah. So this ingestion part, basically, we will ingest it into this kind of storage, and the storage will have to be able to store at large scale because of the amount of data. Yeah. And not just relational data, but also unstructured data. Yeah. And this is where things like HDFS, blob storage, and all this comes into the picture. Also, things like streaming data, right? So streaming data meaning data that is real time, right? So it's not just processed by batch at the end of the day, for example. So this is data coming in every second, right? Milliseconds and so on. And we want to be able to compute, right? Do transformations and analyze that data as soon as possible. Okay? And at the end of the day, the result still going back to the dashboards and applications for the user to view. Okay, so this is sort of the evolving approach to analytics. Yeah? So basically to say that, yeah, things are changing. Of course, a lot of us are still using this, and this will still be relevant. It's just that if you want to go into big data, do things like machine learning and so on, then a lot of this approach may have to change. So essentially, to break it down, this is our job as a data analyst. Yeah, when you want to build as a data analyst or a data scientist, your job is to essentially take these blocks, Lego and so on, and build it into something that makes sense to your end users, right? Or at least something that looks as if it makes sense to the end users, right? Or at least this is what people think our job is, right? But in reality, this is how our job actually looks like, right? It's not just a bunch of Lego stacks, it's a whole warehouse of Lego stacks that you need to take, transform, and then make into something meaningful. Okay, so let me just check if you have any questions. Okay, cool. So no questions so far. All right, so I'll move on. And we're going to start off by going through that slide that I showed you earlier. Yeah, so the modern data warehouse, as I mentioned, we have all your data sources here, and the first thing you want to do is, of course, to ingest that data. Yeah, so what are the tools available in Azure to help us with ingesting that data? Yeah, so after ingesting, then we go to store, prep, model, and stuff, and I'll go through each of these products quickly, yeah, because a whole bunch of products here. So this session mainly, I will just go through all of these products quickly, give you the overview of each product. But be aware that some of the products doesn't mean that if you are storing it, you cannot use it for preparation, right? I just put it here because this is the general function that it does. Yeah. So for example, like the big data cluster can also do transform and clean. Databricks can also do serve and so on, right? But it's just put into these components here, right? So let's start off with ingestion. Right? Ingestion is essentially the process of loading your data and putting it for storage. Yeah? And in this case here, the main tool in Azure is the Azure Data Factory, right? So you can think of this as ETL as a service, which is sitting in Azure, right? And it is mostly code free, right? So it's a multi-cloud and on-prem hybrid. You can copy data from different types of storage, right? From different cloud as well. There are more than 90 native connectors to all kinds of data sources that you want to connect to, your SQL Server databases, CSV files, relational, non-relational data databases, video, audio, binary files, and so on. It's also serverless and auto scale, right? Meaning you don't actually have to deploy a server at the beginning. Yeah, so you essentially you just get charged for what you use, right? Although there are certain startup costs and so on. And the thing is that you can then create control flows for all of these data pipelines, and of course all the basic workflow constructs like loops, branches, conditional execution, and so on. You can put into your pipelines to do the transformation of the data. You can also now actually execute data transformations in Spark, right? So you can actually call out a Spark runtime and allow Spark to do the data transformations for you. Yeah. There's also a runtime for SSIS. So if let's say you already have some of your integration already done in SSIS, you can actually call the SSIS within Data Factory to perform some of these transformations, right? I'll talk about SSIS more in a while. And the thing is that the designers for the design for this data flow and the control flow, most of these are as in like drag and drop kind of designer, and you don't really need to write any code for it. Right? And of course, you can schedule the you can schedule all the data pipelines to run at a certain time or based on a type of trigger. And at the end of the day, you can still monitor everything, right? As the executions are running, you can see how it's performing, where it's stuck, and you can establish alerts and notifications, for example, if let's say something goes wrong. Okay. So that's basically the Azure Data Factory. Yeah. Within the Azure Data Factory, you have the copy data tool, the mapping data flow tool. You can compose the storage, the data processing movement, and so on. You can auto scale it or create it at a certain scale and reduce it when it's not so busy, for example. So things like that can be done easily. So what's the use case for using Azure Data Factory? I would think, yeah, this is actually the quite simple choice, because there's basically just one tool for this, right? Unlike the rest, there's a lot of tools that you can do for different things. So in Azure for ETL, you essentially just have the Azure Data Factory. Yeah? So any new project that you have on the cloud, I think, and if you're on Azure, you should probably go Azure Data Factory, right? If let's say you have some data that is still on-prem, or you have some data that is in your SQL workload or even in SQL Azure, but you have created SSIS packages for them, you can still use Azure Data Factory by using the SSIS integration runtime. So that Data Factory call the SSIS package, and the SSIS package, because you've already done all that development, you don't have to redo it again. Okay. I'll talk a little bit about SSIS as well. So those of you familiar with SSIS, you will know that this is a very powerful product. It's an enterprise level ETL tool used for many, many years already with a wide variety of data. So those of you familiar with SSIS, you will know that this is a very powerful product. It's an enterprise level ETL tool used for many, many years already with a wide variety of data sources as well. If you are, for example, if you still have a lot of data on-prem that you need to move to the Azure data warehouse, then you can still continue using SSIS by all means. There is an Azure feature pack for integration services so that it allows your SSIS to connect to Azure and load the data directly to your data lake, for example. Yeah, and it also has a very rich set of built-in tasks and transformations, graphical UI. A lot of people love this tool. I love this tool as well. So yeah, I don't think it's going away, and it's still very useful for if you have a lot of data which remains on premise. And of course, because you already know how to use this tool, you don't have to learn a new product. So that use case still exists for SSIS. Okay. So let me see if there's any questions.
There's actually one question. Can ADF extract data from SAP Cloud from Chin Weng Tai?
I believe so. We will have to check into the. I know you can extract from SAP, but the SAP Cloud, HANA, and so on. I think because if you look at the ADF data sources right now, it's quite similar to what you get in Power BI. So if you see in Get Data, do you see that in? Do you guys know if SAP Cloud is in there? I think it is. So if you have SAP Cloud there, but this is something we can check very quickly. Yeah. Basically, you just need to key in your authentication and it should be able to extract. But yeah, maybe let me double check on this later. Yeah. Okay, so the next item we want to talk about is on storing all that data that you have ingested. Yeah, and for this we have a few choices. Let's start off by looking at the Azure Blob Storage. Yeah, so yeah, this is primarily the first type of storage that was available on Azure. It's just a highly scalable object storage for all your unstructured data, structured and unstructured data. Yeah, it's a serverless Azure storage service, meaning you don't have to kick up any servers for it. Right, it's just there, and it automatically scales as data is uploaded. Yeah, so you can store basically infinite amount of data in there. You just have to pay for it. Yeah, so you can store images, videos, documents, audio, and so on. Right? And within the blob storage, there are three types of blobs. You have the block storage, the append, and the page. Yeah, the blob storage are the ones that are mutable. Mutable meaning that you can update it. Yeah, the append and the page are immutable, so it's just storing there. If you want to update it, you basically have to delete and insert again. Right. There are replication options for this blob storage. Won't go into so much details, but essentially things like LRS, GRS, and so on is whether it is locally replicated or geographically replicated for more redundancy. Yeah? So locally means it's just replicated within the data center, the Azure data center. Geographically, it gets replicated to other zones or other data centers around the globe as well. Yeah. So not just for redundancy, but also for let's say you have users from another geography that can access those objects faster. Right? There are three storage tiers for this: hot, cold, and archive, with different kind of pricing. Right? So hot are the ones that are readily available. Cold might take a little while for you to access it, and archive usually takes the longest time. Yeah. The thing is, you can move these objects around these different tiers quite easily, right? And quite transparently. Okay? Also, in terms of security, all your data is encrypted at rest and also in motion. So yeah, security is built into Azure Blob Storage. Okay. Now, this Azure Blob Storage, of course, very useful for you to store your unstructured data. Now, you can also store your data into Azure Data Lake Store, or ADLS. Now, this is there's Gen 1 and Gen 2. So what this is it's sort of like a file system in the cloud, right? Optimized for big data analytics. You can think of this as something that has more structure. It has a directory access, it has folders and so on. Whereas blob storage is actually just space for you to dump everything, right? It doesn't really have a file system and so on. Even if it's a file system, it's more of a something that is abstracted. It's not a real file system, right? So whereas the Azure Data Lake Store, there's still no limit on the number of files or the size of the data that you can store, but it has a file system. It is Hadoop compatible, meaning you can. It has the something that looks like HDFS, right? And now there is also in Gen 2 there is also a driver that allows you to access. That means all the Apache Hadoop environments can actually access data in Gen 2. Right? It also supports things like ACL and POSIX permissions for your role-based access control, right? So you can actually control exactly who can access those objects in your data lake store. And it also is able to integrate with Azure AD for authentication, right? Whereas the blob storage, it uses sort of a key for authentication, right? And with Data Lake Storage Gen 2, it converges with the Azure Blob Storage, so that the Azure Blob Storage is generally cheaper than Data Lake. So if this is one of the things that you are wondering about, so Azure Blob Storage is generally cheaper, but in Gen 2, it stores a lot of the backend stuff here in Azure Blob Storage, actually, right? So you can think of this two actually converging over time, and I won't be surprised if later they just become one single product. What this means is that Gen 2 in a way is actually cheaper than Gen 1, but there are some features that are different between the two, Gen 1 and Gen 2, so you have to look into it in more detail, as you go along. So what are let's say you want to store data in Azure. So let's take a look at the side-by-side comparison between the two. For Azure Data Lake Store on the left and the Azure Storage here, what is the API? The API here is using the Web HDFS, the Hadoop file system API, whereas the Azure Storage one is just a normal REST API. Both of them have HDFS compatible interface, but I would say the Data Lake one is a more natively built one. Authentication, this is based on AD, whereas the Azure Storage is used on the keys, shared secret account keys. So probably the AD one is more secure. Authorization, this one has POSIX access control list, so very quite industry standard. Whereas for Azure Blob Storage, you again use back your shared secret keys and account access keys and so on. Encryption, both have very good encryption. So server-side encryption is used for both, right? SLA 99.9% uptime for both. In terms of performance, you can say that the Azure Data Lake Store is more optimized for parallel workloads, because behind it, as you can see here, it has loads of data nodes that can process in parallel at one time. So if you are concerned about performance, generally the Azure Data Lake Store will perform better for if you are running workloads in parallel, right? In terms of capacity, there's no limit in the Azure Data Store. Azure Storage, I said infinite just now, but actually no, there is still a limit, which is about 4.77 terabyte per file, right? Which is huge, and 500 terabytes per account for a single account, right? Don't think most of us will reach that. kind of limit anyway. Yeah. Data lake store is not available in all regions, but is in the Southeast Asia region, so no issue there. Yeah. Azure storage, yeah, it's been around a while. It's in all regions. Okay, I'll also talk a little bit about SQL Server 2019 big data clusters, although this is technically it's not an Azure solution. This is also another way for you to store big data. If let's say you have some on-prem data or whatever, for whatever reason you cannot move your data to the cloud, right? So this is alternative. It essentially is sort of like Hadoop and Spark that you can build on-prem without you can actually deploy this into Azure as well through Kubernetes, but generally, yeah, if you let's say you have a requirement to build a Hadoop store or a kind of a big data cluster with both storage and compute on-prem, then you can look into this as a alternative. Yeah. So the SQL Server 2019 big data cluster, it's essentially you build your own data lake. It has the Spark engine there. It supports Spark streaming, and it also have, of course, SQL Server right there, and HDFS, Hadoop distributed file system. And it also has Polybase. Polybase, I'll talk a little bit more about it later. Polybase is basically allows you to do data virtualization, right? You can connect to different data sources and query it as if it is part of the same data, part of one database. So the use case for this is maybe you want to build a hybrid cloud, right? Where some of the data is on-prem, the rest of it you want to push to the cloud. So on-prem HDFS with a multi processing, parallel processing option. Okay, so as I said, yeah, maybe you have some requirements for this, then this is another alternative that you can look at. Let me check if there are any. No questions? Okay. All right, the next thing we want to cover is a little bit on the preparation side. Yeah, so after you store all that data, you would need to do some transformation, I expect, yeah, some transformation, cleaning of the data, depending on what purpose you have for the data. Yeah, so here we will go through some of these services or solutions that are available in Azure today. Okay, we'll start off with Azure Databricks, right? So Azure Databricks is actually an Apache Spark-based analytics platform, which so Databricks itself is actually a separate company, right? It's a private company that was set up by the founders of Apache Spark, and they come up with this product and service called Databricks, and you can use their platform as well. But the Azure Databricks is they work together with Microsoft to come up with a cloud solution for Databricks, and they put it on Azure. Yeah, so this is a collaboration between Databricks and Microsoft to come up with Azure Databricks. All right. So what Databricks is actually, if you are familiar with Apache Spark, it has all the functionality features of Apache Spark, but it has additional optimization for Spark. Yeah. So it has for example, the Azure Databricks, it gives you a one-click setup, so you can just essentially set up your workspace within a few minutes, yeah, and then you can have your Azure Databricks cluster up and running already, and you can use notebooks in write your code in R, Python, Scala, or even SQL, right? And so it gives you the full power of Spark to clean, curate, and process data. And so Spark is an analytical platform that processes allows you to apply transformation to massive amounts of data at scale. Yeah, and because it does this mainly in memory, so that's why you can get the kind of performance optimization compared to things like Hadoop or even like traditional SQL and so on. So yeah, Databricks is one of these platforms that you can use for analyzing all that data that you have brought into your data lake, and do the kind of transformations that you want. And so the use case for this, I would say, is if you are already comfortable with Spark, right, and notebooks, then this is definitely one of the things that you want to look at. It's a very it's been growing quickly, getting very popular. If you need integration with your Azure Data Lake, with SQL Data Warehouse, Cosmos, DB, Blob Storage, and all this, these are all built into the Azure Databricks. And also another advantage is that it's very quick to, very easy to build, right? You have auto scalable clusters, and you can build it, as I said, in 5 minutes. You can create the cluster and bring up the workspace, maybe 10 minutes, bring up the workspace and start your development on it. Yeah. So I'm going to show you a quick look at how the Azure Databricks looks like. Yeah. So first of all, of course, you have to provision your resource, your Databricks resource in Azure. And once you've done that, you get a workspace. Okay. So yeah, from here you can launch the workspace, and this is where it brings you. Yeah, so within the workspace, you can specify your users, your notebooks, and so on. But this is where you can create your cluster. Yeah, so I've already created a cluster, but you can see that. Let me just start this cluster first, but you can see that it's actually very easy to create a new cluster. All right, so just give the cluster a name. You can specify the cluster mode, high concurrency, standard, or single node, the most expensive, medium cost, cheapest cost. Okay, so you can also specify the engine, the Databricks runtime engine, right, from version 8 all the way latest version 8.2 to version 6. Yeah, whether you want to use GPU or not for the processing, right, and whether you want to enable auto scaling, right? So auto scaling means you can have you can specify a minimum number of workers to the maximum number of workers, and it will actually auto scale based on the job that you submit. Yeah, and the good thing about this is that it is also you only get charged for the amount of activity that the cluster uses. Yeah, so I can say let's say terminate after 30 minutes of inactivity. Right? So the cluster automatically shuts down, terminates, and then you don't get charged for. You still get charged for your storage, but not for the compute anymore. Right? So here you can specify the type of cluster, the amount of memory that you want to provision for this particular cluster, and the type of driver you want to use, and other options. For example, you can create init scripts for Spark and so on. You can also connect directly to your Azure Data Lake store over here, yeah, so that the data can be accessed directly from Databricks. Okay, so I've already created a cluster, so I won't create it here. Yeah, but generally, yeah, if it depends on the number of the worker type that you have, right, and how many cores you're provisioning. But yeah, I would say you can provision a cluster within 5-10 minutes. Okay, so I've already created this cluster, and why is it not starting? Is it starting? Okay, I think it's starting. Yeah, I started it earlier, but I think it must have terminated because I haven't used it for. I put there just like 15 minutes before it terminates. Right. So how you would use the Azure Databricks usually would be through you can do your development using notebooks. Yeah? So over here you can connect to the cluster and run your notebook through that cluster. And yeah, so if you're familiar with notebooks, right, you can see that you can essentially put in documentation as well as code within the notebook and run the commands directly from the notebook and see the results in the notebook and also do a bit of analysis in the notebook as well. Yeah. So I'm just waiting for it to get started. And this is a sample notebook that I've created that allows us to connect using. So over here, this is the default language here for this particular notebook is SQL. Yeah, so it will use SQL to connect to our path to a particular data set here. So this data set here, you can use, if you've already connected to your data lake, of course, you can change the path and connect directly to the data lake and run it from there, right? So let me just, I think if I run it now, probably, yeah, waiting for cluster to start. Okay, never mind. Oh, okay, it started. Yeah, so it started attaching to the cluster, and you can see it starts. You'll start loading this data from this CSV file and creating the table within the cluster. Okay, the first time you run, yeah, it takes a little while because of it's just attaching to the cluster. Let me see if there are any questions. Okay, so I think Pure, you replied yeah, so I guess there is such a connector, yeah. Yeah, so some other things you can do here is, of course, you can schedule once you've developed this notebook, right? You can run it, test it out, develop, and so on, and it's ready. You can schedule it to run at a certain time. You can also use, just now, like the topic about ML, auto ML, and so on. You can actually push this to ML flow to do analysis for the data that is transformed from this Databricks. Okay, never mind. I'll come back to this later while it's attaching to the cluster. Yeah. So sorry about that because I think the cluster terminated while I was talking. So we'll come back to that demo in a while. Yeah. Now, another product in the Azure that you can use for transformation and cleaning is Azure HD Inside. Yeah. And Azure HD Inside is essentially a Hadoop implementation, right? It's an implementation of Hadoop in Azure. Yeah. So all the components from the Hortonworks data platform are actually in there, but there are also some additional features that are built into it. So, for example, it also allows you to query SQL data, and it also have a Spark engine inside. Yeah, so something like Hadoop, but more. Yeah. So all the popular open source frameworks like Hadoop, Spark, Hive, Kafka, Storm, these are all built into Azure HD Inside. And so the thing about this compared to Databricks, is that once you deploy this, it is always running and it is incurring costs, right? You cannot pause or auto scale it. That means when you build your Hadoop cluster, or rather your HD Inside cluster, you already have to specify how many cores that you want to provision. And once you provision it, it is always running, right? If you stop it, you have basically you lose everything and you have to rebuild it again. And rebuilding it, this actually takes a few hours to actually build up the initial platform, right? So yeah, this is one of the things that you have to be careful about if you want to use HD Inside. That the cost is there, right? The good thing is that the cost is more or less fixed, so you know at the end of the month how much you're going to pay. But yeah, it is always running whether you are using it or not. Another key difference between like HD Inside and Spark or Databricks is that HD Inside is more, I would say it is more for batch processing. Means you have data coming in at a certain time, and the performance of the processing is not so important. Yeah. So if you're familiar with Hadoop, it uses this MapReduce algorithm, and from there it processes and transforms your data according to how you to your requirements. But it does this mostly using on distributed computers and commodity disks and so on, right? Or of course now it could be all on SSDs and so on, but it's still on disk. It's still mainly a disk-based platform. Whereas the Azure Databricks is mostly in memory. So a lot of the processing is done in memory. So cost-wise, probably the initial cost for Azure Databricks might, I mean, if you're looking at like for like based on cost, Azure Databricks might be more expensive. But because Databricks, you can stop it while it's not running, right? So in the long run, you have to evaluate the cost. Whereas for HD Inside, it is mostly disk-based, and the performance is slower. I would say much slower than Azure Databricks. Yeah. But this is a very mature ecosystem already. You know, Hadoop already a lot of been around a long time. It's 100% open source, and if you already using tools like Kafka, Storm, and Hive and all that, you can continue using it here on HD Inside. Yeah, but you see lately a lot of people are actually moving towards Spark and Databricks. Okay, let's go back to our. Is it still attaching? Let me. Okay, connect again. Okay, so you can see the Spark job is submitted, right? And how many seconds it took to run it. Yeah, so it basically creates a table called diamonds, and from here we can run another SQL command against the Spark tool, against the table in Databricks, and you can see it just queries all the rows from there, the first 1,000 rows. In terms of analysis, you can change this to like a bar. Well, maybe not this one, it doesn't make sense, but you can view it in different types of charts and graphs and so on. Yeah. You can also so you can also change the language here by putting this percentage point here. So so here in the notebook, we are changing the language to Python and querying this same table using a Python query. And as the job is running, you can actually view it in Spark, right, to see how it is running and visualize it as it is running. Yeah, as all the steps are running. Of course, this is a very small table, so it completes quite quickly, right? But if it's a long running process, yeah, you can actually go in and navigate and see how it is being run. Okay, I think I already saved this table earlier, so that's why there's an exception. But yeah, the table is already created, and over here we can see this is another SQL command that we are running in Databricks. Yeah. And you can see, yeah, the job submits, and very quickly you can perform analysis on this in table form, chart, and all types of different charts available. Right. Okay, over here we are going to do the same thing, but instead of using a table, we will convert this. We will use this using a data frame. Right? So data frame is actually an Apache data frame that allows you to run that command across multiple nodes in the cluster. Okay, completed. And yeah, so this one is using the data frame instead of using the table. Okay, so I mean, this is just very quick overview of showing you some of the things you can do in Spark. Yeah? You can use SQL, you can use Python, different type of languages, and also you can create like the data frame and start analyzing it within this notebook as well. Yeah, and also the cluster, as you can see, it is quite quick to set up. Right, and from here you can see all the tables that are created within the cluster, and you can decide what to do with it using the Spark and Databricks job. Let me see if you have any questions. Okay. So just let me know, yeah, if you have any questions on this. Yeah, so not much time, so I'm going to continue with the rest. Yep. So apart from Databricks and HD Inside, you can also use Polybase, which is in Azure Synapse Analytics, to do the transformation cleaning. So Polybase is actually a technology that allows you to access external data, whether they are stored in your Blob Storage or in your Azure Data Lake, via the TSQL language. Yeah, so essentially you can one of the challenges, for example, if you are a SQL guy, right, is that you have to start learning languages like Hive and Pig and all that to query data that is in your Blob Storage or data lake. Yeah, but Polybase allows you to sort of use TSQL, right, to query all this kind of data, right? So you don't have to learn a totally new language just to start your transformations, right? So this can be called via the Azure Data Factory SSIS, or you can use Azure Functions to perform the orchestration. Okay, but this feature is available in the Azure Synapse Analytics, and I'll talk more about this Synapse later. Yeah, so the use case for Polybase is if you are familiar with SQL, you don't want to deal with Spark or Hive, then yeah, Polybase is an alternative. Yeah. Okay, another one which is quite recent, another way for you to start transforming data is by using Power BI data flows. Yeah, I'm not sure how many of you familiar with this, right? But within your Power BI, there is this thing called Power data flow that you can create, and it's basically like Power Query. Right, so you can select your sources here and so on. Yeah, I've already created one data flow here. And if you are familiar with Power BI, you know that there's Power Query, right? Where you can connect to data sources and do your transformations in Power Query. Yeah, so essentially Power Flow is this Power Query, and we package that Power Query into a flow, and then you can actually use this flow for your ETL, right? And do all your transformations, and you can then use this flow. You can schedule it for doing all types of different transformations. Yeah. So it's like a self-service data prep, right? For those of you familiar with using the Power Query tool, data is stored as entities in the common data model. If you're using Azure Data Lake Gen 2, that means you can also store this into Azure Data Lake store if you want additional storage. I would say the use case for this is for smaller workloads, yeah, where you don't need the you don't need to you want the individuals or small departments to create their own ETL, start using the ETL immediately, right, without going through Data Factory or other type of enterprise tools. Yeah, so this is also something that can be looked into. Azure Data Lake Analytics is another feature or another tool that you can use to transform and clean the data in your data lake. Right? So this assumes that you put all your data into Azure Data Lake and Data Lake already, and then you can use analytics to run transformations across that data. Right. So it has dynamic scaling, meaning you only pay as you use. And it uses a language called USQL, which is actually a combination of TSQL and C#. Yeah, so USQL, you use Visual Studio to develop your transformation, and then you deploy it into Azure, and it does all the transformations for you, and you can output the data back into the data lake or some other format for use. Yeah, so the use case for this, I would say, is to replace, let's say, instead of doing all the transformation in Data Factory, which could be a bit slower, you can push everything into data lakes first, and then use data lake analytics to transform these huge amounts of data after it has come into the lake. Yeah, because this one uses, again, distributed processing and performs much faster compared to, for example, if you use Data Factory to do the transformation. Okay, finally we come to the part where we model the data, right, and then serve it out to the users. So here, let's start off by looking at Azure Synapse Analytics. This was formerly known as Azure SQL Data Warehouse. And what this tool is, it brings together several things, right? It has the SQL technology, which is used for enterprise data warehousing. Recently, it also included Spark technologies, which you can use for big data, right? So when it was Azure SQL Data Warehouse, it only had the SQL component, but now Microsoft has integrated with the Spark component as well. And then you can also do data integration and ETL or ELT using pipelines from here. So this is where it has sort of a bit of overlap with the Data Factory. Yeah? So if you want to use Data Factory, push it to Synapse to a data lake first, you can do that. But if, let's say, you want to do it directly from Synapse Analytics, you can also do it directly without going through Data Factory. Okay, and of course, it also can integrate with other things like Power BI, Cosmos, and Azure ML. Right. So there are two main workspaces here: the SQL-based one, and also the Apache Spark one. Yeah, the SQL-based one, it is a massively parallel processing architecture, meaning that it basically it is like a SQL database, but stretch across the minimum of 60 servers running a single query. Right, when you run a query in in this Synapse Analytics. Okay, I'll just show you the interface of how this looks like. Yeah, so this is the Synapse Analytics workspace in Azure. You can see here you can, I've already provisioned a SQL pool and all the tables that you can load into the SQL pool. There is also a Spark pool that you can load in. And when you do your development, you can create scripts that like SQL, right, like normal SQL, and you can actually run this on your SQL pool, and you can see it runs very, very quickly, even with massive amounts of data, right? And this is like normal SQL statement, right, that you can you're familiar with. For the Spark ones, they are developed using the notebooks, just like the Databricks. Yeah? So you can actually you can run all your Spark notebooks within the Synapse Analytics workspace over here. Okay, in the integrate, this is where you can create additional pipelines to, as I said, to load data directly into the Synapse. Yeah, so instead of going through Data Factory, you can actually do some of that integration work here as well. Monitor is where you can monitor your pipeline runs, meaning the ETL stuff, and your SQL requests as they are running. Yeah, let's say you're running a long-running SQL request, you can actually see where it is running and where it is, how many servers are running it, and so on. Okay. And in the manage, this is where you can create additional pools for your SQL. So this one, it supports, for the SQL workspace, it supports both the serverless SQL engine as well as a dedicated one. Right, the serverless one is there by default, meaning if you have some SQL queries that you want to use, you can immediately use this serverless one. But if, let's say, there is a specific configuration of size and compute that you want to use, then you can create a separate dedicated space for your SQL engine. Okay. Okay, maybe just quickly go through what is the use case for this. Yeah, if you have ad hoc queries or operational reporting that can benefit from massively parallel processing queries. Yeah, we're talking about SQL queries, yeah. Because if you compare to running on a normal SQL database, this typically run 20 to 100 times faster compared to if you just run it in a SQL database. Of course, we're talking about from huge amount of data. Yeah? But one of the constraints is that it is limited to 128 max concurrent queries. Yeah? So if it's not meant for huge number of users accessing the data warehouse at the same time, right? So because of the 128 max concurrent queries. Yeah? But if, let's say, you have this kind of reporting requirements, SQL database is too slow, then you can consider moving it into the Synapse Analytics for the SQL-based partner, right? For the Apache Spark integration, this is mainly here to help those who have some Spark requirements, all right? But if, let's say, your requirement is purely for Apache Spark, then probably it's better to use Azure Databricks, which is more natively integrated with Apache Spark. Okay, let me see how much time I have. I think I'm exceeding about the time. Is it what's the time?
I think you still can.
Still okay?
Still going, yeah.
Okay. I'll try to make this as fast as possible. So we also have Azure Analysis Services in Azure, right? And this is sometimes where it gets confusing, right? What's Azure Analysis Services? What is Synapse, and so on? Okay, and yeah, I agree there's some overlap between analysis services and Synapse. Yeah, Azure Analysis Services, if you're familiar with analysis services in SQL, yeah, it is essentially that, but in the cloud. Yeah, so Azure Analysis Services, it supports in Azure, it only supports the tabular model, yeah, of aggregated data. So analysis services is in memory. Yeah, so compared to being disk-based, right? It's in memory, and usually it is run as a direct query in direct query mode, meaning let's say you have reports in Power BI that are querying, instead of importing all that data, you have massive amounts of data, then it might be too much to import all that data in. You can use Azure Analysis Services to aggregate that data and then use direct query mode from Power BI. Yeah. It also has the ability to scale down, scale up, pause, and resume. So you don't you only get charged for when you are actually using it. Right. Now the use case for this, I would say it is again more because it is meant to help you to aggregate your data, right? Create your model and then aggregate the data. If you have queries that need to run much faster compared to even running in Synapse, yeah, you can consider analysis services. So usually this can be integrated with your Power BI reports and dashboards very seamlessly. It's also has much higher concurrency compared to Synapse, right? As I mentioned just now, Synapse has 128 connection limitation. Analysis services does not have that limit. Yeah. The thing is that this is probably not suitable for like ad hoc kind of queries, yeah, because you need to build that model, that tabular model already, right? Something like your star schema in analysis services, so it has to be pre-aggregated in advance, and that's how you can get that kind of extremely fast response time, right? But if you are just going to query like this particular user did what at this time on this day for that one single transaction, then it is not going to be fast. Yeah, it's not that kind of purpose for it as well. Okay, so yeah, hope that this makes sense to you using when to use Azure Analysis Services. Okay, of course, you can still continue using the Azure SQL database as a storage, as a model and serve in the data warehouse. Yeah, Azure SQL database is a cloud database as a service available as a single database or in the Elastic pool or as a managed instance. And you can have your database size up to 4 terabytes in size for your premium tier. But there is also a hyperscale service tier where you can upgrade the database all the way up to 100 terabytes in size. Yeah? So you can consider using this even as your data warehouse storage, yeah, and to serve it out as well. If let's say you are using it for read only, yeah, you can actually you have this read scale out feature to load balance read only workload. So the data can actually be distributed across several servers as well, so that performance can be improved. Yeah. One tip on this is to actually use clustered column store indexes if you want. If your database is purely for OLAP purposes, right? Then consider using clustered column store indexes. Right? Because SQL database in general is mostly used for OLTP. Yeah, but it doesn't mean that you cannot use it for OLAP as well. Yeah? So I have customers with, I would say, smallish databases that can be served by using just an Azure SQL database instead of Synapse analytics, and they can save a lot of cost by just using a Azure SQL database. Okay. So some use cases on this, if let's say you're already moving from an on-prem database, which you have where you just require a relational database, you don't need a lot of unstructured data and so on, then yeah, you can just consider using Azure SQL database for this, yeah, but mainly for smaller data warehouses. Yeah, if you need the performance and scale and all that, then consider moving to the Synapse Analytics. An option instead of using the Azure SQL database is to actually deploy your SQL Server in a VM, yeah, and then run the full version of SQL Server in the VM. You get full control to the operating system, and the use case for this, I would say, is maybe you already have this solution in your on-prem, but you want to move it to the cloud, or yeah, and you want to use existing tools such as SQL Server Agent, reporting services, SSIS. Yeah, so yeah, this is just perfect, right? Just move your SQL Server to a VM in the cloud. Your database can be more than 4 TB, no issue. And there's also, like, for some customers who have some requirements against some compliance issues where they cannot store their data in the public in the PaaS, as in the platform as a service, then they can consider moving this as a VM in the cloud. Yeah. Finally, I'll just talk a little bit about Cosmos DB. Yeah, Cosmos DB is also another product in the Azure, and this is actually the NoSQL database that is supported by Microsoft in Azure. Yeah, so if you want, it's a document, key value, white column, graph. You want to store this kind of structures in your database. Yeah, then Cosmos DB is perfect for this, and it is schema agnostic and horizontally scalable. Yeah, and it's essentially a NoSQL database. So again, this is more suitable for OLTP compared to OLAP, but there is a Spark connector for Cosmos DB where you can actually push the data to Spark stream for data warehouse aggregations. Yeah, because I would say Cosmos DB by itself, it is not very good for large scale analytical queries. Yeah? So if you can use it for storage, and it works very well, yeah, for that purpose. But once you want to do data warehouse aggregations, probably you may consider connecting it to Spark for the analysis. Okay, so that's all for my session today. Yeah. In summary, I presented you a lot of different solutions that are in Azure right now. Yeah, and different solutions because there are different problems for everyone. Right? So pick the right solution for your problems. You need to ask the right questions. Like, for example, what is the size of the data, the type of data, the structure, how the latency of the data, how quickly the users need access to the data. Yeah, do they need real-time streaming data, or do they need can they live with batch processing? So these are the questions that you need to ask before you decide on the right tool for the job. Yeah, yeah, and before you start, of course, if possible, do a POC, verify that the products that you recommend gives the required performance before you go full in on the solution. Okay, so I hope that this session is helpful for you to understand more about all these kind of different solutions available. All right, thank you.
Thank you, CK. We actually covered a lot of items. If you know the DP200 course for Azure Data Solutions, we've pretty much covered the whole syllabus for that for DP200. So it's like an overview. Yeah.
Yeah, it's an overview.
Yeah. So yeah, thank you, CK. That's for a very informative session. If you guys have any questions, CK will still be on the chat for a few minutes.
Yeah,
If you want,
sure.
if you want to drop it there, you can.